Humbert. Sorry I couldn't be here today, but I'm going to kind of talk through the review for you so you still have a way to review before you take your quiz with the substitute. So let's go ahead and let's start by this first problem where we need to solve by substitution. So the first problem asks us to solve by substitution, and that's going to be the easiest one to use because this is already equal to y. Y is equal to 2x minus 3. They're the same thing. So where I see y down there, I can take y out and I can put 2x minus 3 in instead. So I have 4x, and now I'm going to take the y out completely because I'm gone. You have a substitute. I don't need to be here anymore. So we're taking the y out and we're putting 2x minus 3 in instead. So then we have 4x plus 2x is going to give us 6x minus 3 is equal to 9. So now we're going to go ahead and we're going to add 3 to both sides. And once we add 3 to both sides, we get 6x is equal to 12. Divide both sides by 6. Again, just solving for x, and we get that x is equal to 2. So now we know that x is equal to 2. They're the same thing. So where I see x up here, I can take that x out completely, and I can put 2 in instead. So I have y is equal to 2 times, now I'm going to take x out and put 2 in instead, and then minus 3. 2 times 2 is 4 minus 3, and then you get 4 minus 3 is 1. So x is 2, y is 1. Now we need to write that out as a coordinate point, x, then y. All right, let's take a look at number 2. So number 2, this time it's solved for x. So I see that this equation already nicely has it set up as x is equal to. So now where I see x down here, I can plug in y minus 4 instead. So I'm going to have y minus 4. I took that x out completely, put y minus 4 in instead. And now everything else is going to stay the exact same. Okay, so now I need to combine like terms. Well, y plus 3y is 4y minus 4 is equal to 12. So then we need to add 4 to both sides. And then I get that 4y is equal to 12 plus 4, which is 16. Now this 4 is being multiplied by the y. So to get it over to the other side, I need to divide both sides by 4. And then I get that y is equal to 4. So now I know y is equal to 4. So I can look up here and I can go ahead and I can plug in for my y. This equation is already solved for x. You can plug it back into whatever equation you want. But I see that that top one is already solved for x. So I'm going to write everything else the same, except instead of writing y, I'm going to write 4. So then I end up having that x is equal to 4 minus 4. So x is equal to 0. So now I can write that coordinate point out. First x and then y. Again, I'm probably talking through this a lot faster than you can do it. So if you need to pause it and take a second to look at it, feel free to take that time. So when we get to number 3, we have a problem because none of our equations are solved for y. So we have to do that. So what we want to do is look for a positive coefficient of 1. So we want to look for a variable that's easy to solve for. So to me, this variable looks easy to solve for. So I'm taking this equation, negative 2x plus y is equal to 4, and I'm going to solve it for y. So I'm going to add 2x to both sides. And then I get y is equal to 2x plus 4. So now y is equal to that. So I've taken this equation and I'm replacing it with y is equal to 2x plus 4. So now I know y is equal to that. They are the same thing. So y is equal to 2x plus 4. So where I see y down here, I can put 2x plus 4 in instead. So I have 3x plus 2 times 2x plus 4. So I took that y out completely, all right, and I'm keeping everything else in the equation the same except for what I took out. So now this 2 right here needs to be distributed into each thing that follows in the parenthesis. So I have 3x, and I have 2 times 2, which is 4x, 2 times 4, which is 6, and that's equal to, 15. Or sorry, 2 times 4 is 8. Good one, Miss Humbert. And that's equal to 15. 3x plus 4x is going to give me 7x plus 8 is equal to 15. So now I'm going to go ahead and subtract 8 from both sides. So then I get that 7x is equal to 7. So to solve for x, I need to divide both sides by 7, and I get that x is equal to 1. So I'm going to go back up. Remember, I made this new version up here. This beautiful version is already solved for y, but it means the same thing as this equation right here. So now I know that x is equal to 1. So I'm going to substitute that in for x there. So I have y is equal to 2 times 1 plus 4. So 2 times 1 is 2 plus 4 is 6. So last but not least, we want to write it out as a coordinate point, x, y. So first my x, and then my y. And that's your final answer. Next, let's take a look at number 4. So the first thing I noticed about number 4 is that we have the same coefficient with the opposite sign. So if we look, the x's both have 3's, and then they have opposite signs. So that means we can go ahead and we can add down the columns. So 3x minus 3x is 0x. Y plus 2y is 3y. 12 minus 3 is 9. So now I can go ahead and I can divide both sides by 3 because 0x cancels out. So because the 3 is being multiplied by the y, divide by 3 by both sides to simplify. 9 divided by 3 is 3. So now I know that y is equal to 3. So I'm going to take and I can substitute it back in. I can either put it in for that one or I could put it in for that one if I wanted. It doesn't matter. You can decide. I'm just going to plug it into the first one. So I'm going to keep the equation exactly as is, but now I'm putting 3 in instead of y. So this is the same as 3x plus 3 is equal to a negative 3. So now I'm going to solve this for y. So I'm going to subtract 3 from both sides. Well, a negative 3 minus 3 is going to get more negative. So I get a negative 6. Divide both sides by 3. Negative 6 divided by 3 is a negative 2. So now I know that x is a negative 2. So I'm going to go back up to this original equation. Or sorry, I already know what my y is. So now I just need to plug in my x and y into a coordinate point. So x first, then y. So the answer to this one is negative 2, negative 3. Let's take a look at number 5. So for number 5, we already have the same coefficients on the x's. So the x both have the same answer, or the same number, but they don't have an opposite. So we need to make an opposite. So I'm going to take this second equation and I'm going to multiply it by a negative 1. When I do that, that's going to change the sign of every single thing in that second equation. So let's rewrite that out. So we have 2x plus y is equal to 5. So that's going to stay the same. Then this down here, this second equation, I'm going to go through and change the signs of everything. That doesn't change the value of the problem because I changed the signs of everything. So now we can go ahead and add down the columns. 2x minus 2x is 0x, so those are going to cancel out. Good, that's what we wanted. Y minus 3y, so that's the same as 1 minus 2. That's going to give me a negative 2y. And then 5 minus 3 is going to give me 2. So now I want to go ahead and I'm going to divide both sides by a negative 2 so I can solve for my y. 2 divided by negative 2 is a negative 1. So now I know that y is equal to a negative 1. So where I see y up here, I can plug it in, and it doesn't matter which one. Again, I usually just pick the top one. So I have 2x plus, now I'm going to plug in a negative 1, is equal to 5. So that's 2x minus 1 is equal to 5. So now to solve for x, I need to add 1 to both sides. 2x is equal to 5 plus 1, which is 6. Divide both sides by 2, and then I get that x is equal to 3. So my x and my y coordinate, I have 3, negative 1 for my solution. Let's take a look at that last solving by elimination problem. So for this one, I don't have the same coefficient, and I don't have the opposite sign. Well, let's just take a look at our x's. Okay, so I have a 2 in front of this x, and I have a 4 in front of this x. So I'm asking myself, okay, what can I multiply 2 by to make it 4? Well, I can multiply 2 by 2 to make it 4. Okay, good starters. Do I have opposite signs? I don't. So I'm going to multiply by a negative 2 so that I get opposite signs. So I'm taking the second equation and multiplying it by a negative 2. So then I get negative 2 times 2 is a negative 4x. Negative 2 times 5 is a negative 10y. And negative 2 times 7 is a negative 14. The second equation I did not do anything to, so it's going to stay the same. And now I have same coefficients with opposite signs. So I can go ahead and add down the columns. Negative 4x plus 4x is 0x, so that's going to cancel. Negative 10 plus 10 is 0, so that's going to cancel. Negative 14 plus 14 is 0, so that's going to cancel. So we end up having 0 is equal to 0. Well, guess what? 0 is always going to be equal to 0. So that means that we have infinitely many solutions for that one, or IMS. All right, let's take a look at number 7. So to graph these, we need to graph them and then see where they cross. That's how we're going to solve this system. So you don't have to do any solving systems by substitution or elimination. You just have to graph. So for this one, we're crossing the y-axis at 5, and then our slope is 1 or 1 over 1. So we're going up 1 over 1, plotting that point. So now I'm going to go ahead and I'm going to connect this line. And there's my first one. Next, let's take a look at this next line. So we're crossing at a negative 1. And then our slope is negative 2 or negative 2 over 1. So we're going down 2 over 1. And we're graphing that line. So I'm guessing that it's crossing at about that point. So I see that to get to that point, I have to go left 3. So I'm going left 3, and then I have to go up 3. Remember, coordinate points are x, then y. So I estimated my point to be at about negative 3, 3. Let's take a look at this shading problem. So they're both in slope-intercept form, so I can go ahead and graph this. So I'm crossing the y-axis at a negative 1. And then my slope is 2 over 3. So I'm going up 2 over 3. So those are my 2 points I need to connect. Well, I notice that my alligator does not have a line underneath it. So this is going to be a dashed line. Then I notice that the alligator mouth is opening towards my y, so I need to shade up. Then, for this problem, I see that we're crossing the y-axis at 2. And then we're going down 1, right 1. And it's going to be a solid line. It's a solid line because there's a solid line underneath here. And again, the alligator's facing away from my y this time, so I'm going to shade down from my line. The area that they're overlapping, I see, is going to be right here. So really, when you're doing this, make sure your overlapping shading is really, really obvious to me. Okay? All right, let's take a look at number 9 and 10. So we need to write these in standard form. So remember that standard form is ax plus by is equal to c. So I need to get my x's and y's on the same side and the thing that's just a number or the constant on the other side. So I need to get this 5y to be on the same side as my 3x. Well, I see that it's a positive 5y. So I'm going to go ahead and I'm going to subtract 5y from both sides. So then I get 3x minus 5y is equal to 11. And that's all I have to do. I don't have to combine anything else. I just need to get my x's and y's on the same side and a thing that's just a number on the other side. Well, let's take a look at this one. 3x plus 7y minus 2 is equal to 15. Well, my x's and my y's are already on the same side. But this thing that's just a number shouldn't be on this side. It should be on the other side. So we need to add 2 to both sides. So we get 3x plus 7y, and then 15 plus 2 is 17. And that's your final answer, okay? So thank you for listening to this. Once you're done, go ahead and show the substitute that you finished your purple review sheet, and you can start the quiz. Please stay quiet until everybody's finished their quiz, so be polite. There are calculators available up front if you need them. So guys, thanks for listening, and I know you're going to do great. I'll see you next week.